Hello, and thanks for joining us. Today, we're going to be seeing how machine learning techniques can be used to build predictive models that help maximize the value of your data. If you've been following our series, you'll already have seen some of the benefits that can be achieved by democratizing our data, how effective use of your data could improve your problem solving, accelerate your time to market, and reduce your costs, all by focusing on the efforts that actually bring results quickly. If you'd like to hear more about any of those topics, we can always go back and watch some of those on demand on our website. I'm your host, Stuart Little, and today we're going to be looking at how the use of predictive modelling techniques enables continuous improvements of your products and processes. You'll see how complex industrial data can be effectively modelled, and these insights efficiently communicated across your organisations. You'll also see how these methods can be put into the hands of your scientists and engineers, allowing them to combine the powerful methods with their own domain expertise. This is going to allow their time to be concentrated on building detailed process understanding from your data and helping you to make better decisions with that understanding. You're going to learn poor hay fever. You're going to see how these methods can be put into the hands of your scientists and engineers, allowing them to use their domain understanding to build predictive models that will accelerate your processes and save you time and money. And we're also going to hear directly from an expert who will discuss the value of these tools and how to identify and overcome the barriers to adoption in your organizations, so you can start implementing these methods sooner. Additionally, we're going to see demonstrations of what these methods look like in practice, using case studies that anyone working in industry can relate to. These will illustrate how to efficiently generate effective predictive models of industrial data, and also how to model complex curved data, such as chromatography data. What we're hoping is that the key things we're going to leave here with will be an understanding of how we can get started applying machine learning techniques to your data to maximize the value you obtain from it. The importance of continuing to understand and use your domain knowledge, experience, and intuition alongside these statistical methods. Hopefully going to leave with an understanding of the impact bad data quality might have, the structure of that data might have on the questions we can answer from it. And hopefully we're going to leave with an understanding of how our data-driven processes and analytics can consistently deliver better explainable insights into your data. But first, I'd like to introduce today's guest. Today, we'll be speaking with David Meintrup. David is a professor of mathematics and statistics at the Ingolstadt University of Applied Sciences, and he's responsible for the mathematical and statistical education of engineering students. Alongside his research and academic interests, David is the author of several excellent books and works across industries as a statistical trainer and consultant, predominantly working with the semiconductor, solar, pharmaceutical, and biotech industries. It's great to have you with us, David.
Well, thank you for the invitation, Stuart. It's a pleasure to be here.
Thanks, David. It's great that you're able to join us, and I'm sure it's going to be a very interesting discussion today. And I'm sure many of you will relate to the experiences David has had, and you'll probably recognise and identify with some of the challenges we'll discuss today in your own work. Hopefully, you'll go away with some ideas about how you can apply these techniques to your own data in your own organisations. And as well, to those of you watching this, I'm not going to be the only person asking questions today. If you're part of our live audience, you'll have the opportunity to ask them too. Please just submit your questions via the Q&A tab, and we'll get to those a little bit later on. But before we get into our conversation, I'd like to ensure that we're all aligned on what we mean when we talk about machine learning or predictive modelling. And to assist us in this, a colleague of mine, Massimo Martucci, has prepared a short presentation for us. This is going to help us understand how we might apply these types of methods to our own work. And as you'll see, using the right tools can streamline your model selection and development processes, and in doing so generate actionable insights that can be combined with your own domain knowledge to maximize the value you're obtaining from your data. This combination of subject matter expertise and predictive modelling facilitates data-driven decision-making, and when we do this successfully, can create significant momentum to drive the adoption of these methods, all of which leads to a modernization of our business processes across organizations. Massimo's recorded this for us ahead of time, so let's watch, and we'll see you back here live after the presentation.
Hi, in this presentation we are talking about model screening with JMP Pro. The case study that I'm going to use is about this green polymer production. We have this MFI quality attributes that we want to take into account, and we want to find a good model, a good predictive model in order to explain this MFI, the melt flowability index, with all of some of these potential inputs. We will use the model screening platform in JMP Pro. We will select the methods we want to run. We will run them in parallel, and then we will be able to find the best model that will explain better this MFI. This will be done in terms of these JMP Pro features. First of all, in JMP Pro you have a lot of machine learning algorithms that you can run. So generalized regression, decision trees, neural networks, and so on. And since some of them, or most of them, are prone to overfitting, normally in JMP Pro you use this cross-validation technique, and you select a column with different subsets for training the model, for validate to select the model, and a third subset of test just to compare the different models one by one to find the best model with the less error. So now we are in JMP Pro. We have our data here, and this is the model screening platform. I've already put the response, the factors here, and the validation column, and also selected some of the methods. And when I press OK, all these methods will run in parallel, and the platform will choose the best one, the dominant one, which is this generalized regression lasso with two factor of iteration and quadratic effect that has the highest R-square and the least error. Then when I'm done, I can run this selected and I can go to all the diagnostic and also see if there is some particular aspect in the formula that I want to take into account, and eventually I can also exploit this formula by publishing this prediction formula and eventually go and generate some scoring code, for instance in Python, that will bring me more intelligence to what I'm doing. How can I do this? So before doing it again from scratch, let's see what is possible, by the way, in JMP Pro. In JMP Pro you can have directly go to any machine learning algorithm you want, so neural network or Busa forest or other methods. So if, for instance, you want to go to a neural network, you can select this platform here. You can select your response or responses. You can select all your factors, and here you will also select this validation column. And by launching the neural net, and I will choose the default parameters, it will run the platform, and you will have here in the test subset, you will have this R-square and this error that you want to minimize. This is for neural networks, for instance, but let's run, for instance, another platform. So let's do a Busa forest with the same parameters. So the MFI is our response. We have these potential factors here, and also we have this validation column again. When I press OK again, we will go into the defaults for the parameters, and now we have different values for the R-square and the error for the test subset. We can compare, we can run whatever you want, we can compare all these things one-to-one, but it's much better to do it with the model screening platform. So let me launch it from scratch. I can go to this analyze predictive modeling. I can go to this model screening, and here again, once and for all, I will select the response, I will select the factors, I will select the validation column, and then I can also select all the methods I want to run. Here we have a continuous value for the response, so I'm not really interested in some of those, so the KNN, SVM. I want to focus only on this most important for me algorithms. And what I want to add to these options is that I suspect that they may be also two-way interactions and quadratic effects in my factors, so I will select both of them. And so when I run OK finally here, so all these things will run in parallel, and I will be prompted with this chart in which from the most appropriate to the last one in terms of R square and error, you will go and have all these model listed. Now it's quite easy that is the best model. I can select the dominant and I can run this selected, and again now I'm here and I can go in detail of all the diagnostics, for instance, so I can go to this diagnostic plot, and last of all I could go and see in the profiler what are the main factors that explain the formula, so definitely these three factors here. And if I want to score a new lot of production with the predicted MFI, I can go here and come into these columns. I can publish this formula, and I can create some scoring code in JSL, for instance, or even in other languages such as Python. So I can run this code to another new database. So and now I can score this new data with this predictive model. That's all. Thanks.
Well, I think that was a really fantastic illustration of what's possible with the right tools, and we should thank Massimo for preparing this for us. Clearly, it's a very exciting time to be exploring the possibilities that predictive models can bring to our organizations. And we're going to be speaking in depth with David in a few minutes. But ahead of that, I'd just like to bring him in now to ask his thoughts on what we've just seen, and particularly what the impact of the democratization of predictive modeling through tools like model screening could be to your organizations.
Well, Stuart, I think that the impact of tools like the model selection platform is really huge. I mean, I'm old enough to remember when you basically had to manually implement every single aspect of your model, the parameters, the hyperparameters, etc. So the input was text-based, the output was text-based, and if you just made one mistake, you had to do it all over again. As a result, people tended to stick with one classifier because they had programmed it enough times that they knew all the problems and pitfalls. Now, if you compare that with the model selection tool available now, I think the progress is just amazing. It allows anyone to use a whole range of classification methods, literally in seconds. In addition, you don't really need to know a lot of the details of the models you're using. I mean, the winner of the demo that we just saw, generalized lasso regression, I think is a very good example. I remember I presented a COVID-19 related case study where we used logistic lasso regression at the Discovery Summit last year. And I actually tried to explain a bit of the mathematical details, like the so-called L1 norm. But for non-mathematicians, this is really not obvious. With the model selection platform, you can use it without understanding the details. and then select the best model for your data. A few years ago, this was something that only experts would have been able to do. So democratizing predictive modeling has another advantage. It also makes it easier for teams with different backgrounds to work together. And in the end, the whole team can decide on the best approach. And by the way, it also has a big impact on us as teachers and researchers at university. I mean, it allows us to spend much less time explaining the how-to of the software and allows us to really focus on understanding the concepts and interpreting the results.
Yeah, thanks for that insight, David. I certainly agree with you that if we can reduce the barriers to getting started with building predictive models, it's going to allow those productive conversations to happen faster. And I'm sure we'll be expanding on these topics in our discussion shortly. But before that, I just wanted to touch on some of the possibilities that predictive modeling can bring to our organizations. There's a lot of hype around in the media at the minute, particularly around GPT and similar. But behind that hype, I think it's really clear now that there are a range of really powerful methods that exist in our modeling toolkits. And if we use modern tools like JMP and JMP Pro, we can simplify and democratize access to these methods. And if we do this really well, I think it gives us the opportunity to empower scientists, engineers, to build better processes with that information, finding the best solutions to the problems that we have. And if we take advantage of all of that information we're generating, not just what we can easily identify, easily plot, easily understand. And I think that the other half of that goes with it is the ability that predictive modeling has to bring a more satisfying work experience for people and a better work-life balance. I'm sure many of us have been in a situation where we're trying to solve problems in production. And if we use these kind of data-driven approaches, it can really reduce the time it takes us to troubleshoot the problems that we have. It makes our processes more predictable, more reliable, and ensures that our hard work's actually delivering actionable results, things that we can see the benefit of, and we're not scratching around looking for answers. If all that sounds interesting and you'd like to learn more about the background to data analytics, predictive modeling, then a really good option would be to sign up for our free on-demand modeling workshop. It's available from our website, and you'll receive the link directly to you by email next week. And we'll share some more details of that and some other resources as we go on today. I've already seen there are some great questions coming in. But just a reminder, if we have questions as we go along, please just keep submitting them via the Q&A tab and we'll get to them later. But right now, I want to bring David back into our discussion, and we're going to allow him to share some of his experiences of helping maximize the value obtained from predictive models, both for him in his own work, but also with some of the organizations that he works with. So welcome back, David. I'd like to firstly just to think back to a time or place where you or one of your colleagues, one of the businesses you're working with, was faced with a challenge, perhaps in production and development, that they were unable to effectively model themselves and were left struggling to resolve without help from their relevant data. The data probably existed and contained the solution, but it could have been a challenge to bring it together. Perhaps they were unsure of what was required, or even just didn't know where to start. So as a result, they were unable to use predictive modeling themselves to efficiently resolve their issue. But could you tell us about that? And also maybe a little bit about how you could help them resolve this with predictive modeling?
Sure. So I remember a project where I was consulting in a company that produced one of these really expensive, fancy beverages. And the process actually involved filters. After a while, these filters would get clogged. Then the process had to be stopped, the filters taken out, cleaned, put back in, and the whole process started again. So you can imagine that they had a strong interest in doing this as late as possible. On the other hand, cleaning the filters too late could cause serious damage to the machine. So in this case, the challenge was to predict the perfect time to stop the process and clean the filters. Now, obviously, there's no single measurement, no single variable that directly measures the amount of dirt on the filter or how clogged the filter is. So the task here was to find the right process variables to indirectly estimate the status of the filter. And in the end, in this particular case, there were not too few variables, but too many. The machine was simply packed with sensors permanently measuring all sorts of things. So it took us some time to identify, in the end, 3 variables: a flow rate, a pressure, and a particular compound in the liquid that we could effectively use to predict the condition of the filter and therefore the best time to clean it.
Yeah, I think that's a very relatable example, David. Particularly nice to see one for kind of almost predictive maintenance, I suppose. And then, it's clear that in this case, the predictive models you built provided an effective route for them to generate those significant improvements in that filtration process. Obviously then improves process consistency and reliability. Strongly suspect also reduce the costs if they're not having to replace filters when they don't need to. And I'm sure, it's a very relatable topic, so I'm sure there are people watching this who are thinking of a similar problem they might have. And it might well be why they've registered for this webinar in the first place. The solution is probably in their data. It's just a question of obtaining it, extracting that solution. Obviously, we have tools for that anyone could start using to explore and model their data. But for those people out there, could you tell them how they could effectively utilize their data to generate these solutions to this kind of problem through efficient generation of predictive models that can adequately describe the behavior of that system?
Well, Stuart, if I had the global answer to this for everyone, I could probably make a lot of money. But let's see what can be said in general. So first, I would say just get started. Don't be intimidated by software, tools, people using all the current buzzwords. Most of them, I can guarantee you that from my personal experience, have no deeper understanding of what they are talking about. So just go ahead and start playing with your data. And by the way, I actually think that JMP is perfectly suited for that. It's very easy to use, it's interactive, it gives you all the additional options through menus so that you can try out what works for your data. Secondly, I would recommend that you never skip EDA, exploratory data analysis. So I know this might sound a bit conservative in the era of generative AI and ChatGPT, but personally, I'm convinced that nothing else will give you a better feel for your data than exploratory data analysis. What do you think? Would you agree, Stuart?
Yeah, I think certainly in my experience, a lot of problems that I've looked to model, there've been initial issues that we've identified purely by EDA and taking that approach. I think for those in the audience who maybe don't know or haven't done much exploratory data work, would you be able to expand a little bit on how that fits into the process for the audience?
Sure. So what I understand under exploratory data analysis is that you typically start with generating things like descriptive statistics, plotting your data, for example, with histograms, box plots, bar charts. And then you look for unusual patterns like outliers, unexpected skewness, things like that. And finally, you might want to check pairwise associations or correlations, ideally both statistically and graphically between the relevant factors in your model. So in applied data analysis, it's always very important to look at both statistics and graphs in order not to miss any critical information. Now, back to your original question about how to build good predictive models. So we had just get started, don't skip exploratory data analysis. I would like to add one more point. There's this famous quote by Albert Einstein, make things as simple as possible, but not simpler. And I think that in the context of predictive modeling, this means to me that you should start with the simplest model you can imagine being useful in your case. So in general, I rather recommend that people don't start with models that they don't understand at all. I mean, I'm not talking about understanding all the mathematical details, of course, but just having a good general idea of what the model does and how it works. I think it's helpful for two reasons. First, a simpler model will most likely be much easier to interpret and understand. And secondly, it establishes kind of a benchmark which you can later build on. So when after the first model that you tried, you build more complex models, you can compare them with the simple one and judge if the extra effort is actually worth a gain or not.
Yeah, and I think that's great advice. To be honest, I think, like you say, we don't need to necessarily know the mathematics of all of these kind of models, but if we utilize methods that we understand how they're working, it allows us to adequately explain them. And to be honest, just removes that sensation that we're putting data into some kind of black box that's going to give us an answer that we have no idea where it's come from. I think if we do that, it allows us to have meaningful discussions around what the model's actually giving us and what it's telling us about our process. And I mean, if we do it that way, generally I find it's easier to build those use cases to start rolling out modeling to more and more areas of the business. If you're just getting started and looking for successful use cases to illustrate this to other people, you can find plenty of examples from a wide range of industries on our website. And I think it's also often really easy to sit here and talk about applying these techniques and changing processes based on really good examples. But inevitably, we get some pushback when we try and make these changes. People are often resistant to change because we've done things a certain way for a very long time. There's nothing new in wanting to use our data to inform decisions. But when we get to the point we're building quite complex models, how would you go about making this type of change with people that are unsure, haven't used or seen it before? How do we convince people it's worth trying?
Well, the first thing I try is to make them curious. So in my experience, the best way to do this is through graphs. If you can take their own data and use something like JMP's Graph Builder, for example, to create a graph that shows something they are interested in, it will pique their curiosity. Then I think it's very important as a statistician to be kind and welcoming. So my personal hero, if I may mention him for this, is Phil Kay. And by the way, if you're interested in DOE, I would recommend to follow him on DOE by Phil Kay. You find that on LinkedIn. He always stresses the importance of being encouraging and welcoming. And I can tell you that from my experience over the last 15 years or so, I have literally seen all sorts of mistakes in statistics, and most of them are quite elementary, such as confusing standard error and standard deviation or using the wrong hypothesis test. I think that if we want to encourage people to make the best out of their data, it's really important to applaud their efforts and be supportive and help them get better rather than pointing out their mistakes. And finally, if you want to get people's attention for more than just a second, I think you need to show that there is real benefit to data analysis and predictive modeling. And that's not easy for either side. They will probably know about the low-hanging fruit, so you will not impress them with that. And to come up with something really useful for them, you will have to dig a little deeper into their field. And on the other hand, it may also require some work from the other side, because they will have to make the effort to understand the statistical aspects. So in summary, I would say there's no free lunch, but if there's a benefit, then there's also an opportunity.
Yeah, absolutely. I think if we're able to be kind in these conversations, it can really help increase the curiosity people have. And if we have good examples we can share, curiosity becomes almost confidence of people to go and have a look at their data, plot a graph. Like classically, people say, "Oh, picture paints 1,000 words." For data, absolutely, it's true. And if we do that, we have a really great platform. We can encourage others to join us on this journey. And I think if we support people through transformation, it's always going to be a win. And the reason I think it's going to be a win is because it brings huge benefits. And I think it's a really good time just to touch on those again. When we've already seen, but when we effectively leverage our data, we can improve our yields, we can reduce costs, improve quality outcomes. And if we do that, generally our projects become more predictable. So we get better prediction of timelines, allows us to set budgets, hit deadlines. And if we use the models that result from these processes, it oftentimes will help us quickly find a solution to really complex problems if we have a good model, or it will tell us we need a new model. But we're in a really great place because we already understand most of the process. So if we want to, apply this more globally across an organization, those benefits really have to be shared across that organization. So, there needs to be something in this for everyone. Otherwise, we're going to get resistance. So how do the people actually doing the work benefit? And how does this then help scientists, engineers, as well as managers and stakeholders?
Well, for those doing the work, I think they will very quickly realize that these models allow for continuous improvement because, for example, they can be fine-tuned with more or newer data. In addition, there's often potential for automation, and many of these models are highly adaptable, so you can use them in similar use cases. Scientists and engineers will quickly benefit from the better predictions that these models can produce, shorter development times, hopefully a deeper understanding of the factors that are relevant in their particular processes and products. And from a management and stakeholder perspective, well, as you said, Stuart, I think improved yields, reduced costs, and improved quality will lead to better products and processes and ultimately in a more competitive company with a higher market value. So if I may summarize maybe a little bit, I think that for a company adopting a data-driven mindset, particularly towards predictive modeling, enables them to make better decisions, optimize operations and processes, and gain a competitive advantage.
Absolutely. And I think it's clear from what you've said, you've seen firsthand how these things can happen across organizations if we facilitate analytics. And ultimately, if we help everyone on this journey, not just data scientists, it's going to help us make better data-driven decisions that will give you a real competitive advantage across your organization. Thank you, David. Really appreciate you spending time with us today to share these insights. Obviously, we'll come back to you for the Q&A shortly. I hope that some of you watching this will have got some great ideas of where predictive models could help you maximize the value you retain from your data and how we could extend the impact of this work throughout your organization. I touched on before our modeling workshop. It seems the ideal time just to bring it up again for a bit more detail, We have free 1-hour sessions available, all on statistical modeling techniques in 3 languages, so English, German, and French. And they're all geared towards empowering scientists and engineers to make the most out of their data and generate those actionable insights as quickly as possible. It'll give you a great foundation to solve your problems and derive those insights faster. Links to these sessions, again, will be provided to you via email. And if you have any immediate questions, it's just a reminder to keep putting them in the Q&A box, and I'll put them to David shortly. But right now, we're going to take a look at another presentation. This time, illustrating how, with modern methodologies, we're not limited to building models on individual data points, single numbers. So this was recorded by another of my colleagues, Owen Jonathan, and he's going to show us how we can directly model the shape of complex curve responses instead of those single data points. So in this case study, you're going to see Owen working with chromatography data to optimize the performance of a separation process. You may be sitting there with or without this sort of HPLC data, but this methodology is equally applicable to any type of curve data, be it a simple response curve like yield over time to spectral and chromatographical data. So I'd like you to consider your own situation and then try and imagine how this type of capability could effectively model and describe your own process. So let's watch, and we'll see you back here live after the presentation.
Hi everyone, today we're going to be discussing about the Functional Data Explorer within JMP. First of all, what is functional data? Functional data is basically data that comes in the form of a curve. This could be time data, sensor data, spectral data, and so forth. On the right here, I have an example that we're going to take a look at for this case study. And this is an example of a spectral data where you have lots of peaks. So the reason why we want to investigate functional data is because usually summarizing it to its simple average, minimum, or maximum is often not enough. There's some loss of information there, and sometimes the shape of the curve itself is the important variable that we want to take a look at. So this is a case study using high-performance liquid chromatography example, and it involves the bioproduction of a phospholipid. So these phospholipids are produced in bacteria, and they're produced through a single fermentation process. Now, the problem is that sometimes a single fermentation production can produce massive variation in these structures. So you can have variety in the chemical bonds, the chain length, and the functional groups. So the challenge is when you want to separate or purify a specific compound efficiently using HPLC. So our aim for this case study is that we have a compound of interest here, C18, but the problem is that it's mixed with C17 because they're very, very similar. They're only different by 1 carbon. And so they have very similar absorbance and retention time. And therefore, separating it through HPLC provides quite a unique challenge. So we're going to investigate 2 factors here, temperature and flow rate, which are being changed, and we can see how that influences the shape of our peaks. So before we use the Functional Data Explorer, your analysis might look like this, where you've got this messy analysis of graph, and there's some additional pre-processing time to sort, transform, and filter to the regions of interest that we want to take out from this data. It's very difficult to extract useful information on the relationship between our inputs and outputs, and it's just not an efficient way to do your analysis. With the Functional Data Explorer, we can apply those same transformations in just a few clicks. And what we get in the end is this profiler, which is a visual representation of our model. So instead of looking at those messy graphs with those numbers runs, we just have one simple visual to show the relationship between our inputs and outputs. We also given the ability to optimize our factors to a known standard or optimal target peak. And JMP will use this model to predict which factor settings could produce that optimal standard peak. And with that, we're going to head into JMP Pro to see how we get towards this end final result here. So we are now in JMP Pro, and you can see here this data. We've got our batch ID. We've got this time here, which is our X, and then the intensity, our Y, and the 2 factors that we change between different runs. So you can see that we're investigating flow rate and temperature. If we take a look at a different batch, you'll see the temperature and the flow rate changes. And we also have like this target function, which I'm going to show real quick here in the graph, where this is basically our ideal separation curve. And this is what we want to use as kind of to optimize our peaks. So if we take a look at the raw graphs here, you can see that it's quite a messy graph. There's a lot of things going on here. And what we're interested in here are really these high peaks. So if I just pick one, So these high peak corresponds to our compound of interest, but again, it is mixed with that C17, which is only different by 1 carbon. And as you can see here, this is a run where we change the flow rate. There is a shift in the x-axis for these high peaks. And therefore, like if we were to investigate and analyze this spectra, we will have to make some adjustments, transformations, maybe align the x-axis together before we can start analyzing it. And I'm going to show you real quick how to do that in the Functional Data Explorer and how you can do that in just a few clicks. Again, this is our ideal curve where we've got this really nice separation between C18 and C17. So if we were to zoom in on to those high peaks, so this is where I filtered the X to just this really high peak, we can see that there is really no separation going on in this particular run. As I increase the temperature, we can see that there begins to be some separation between C18 and C17, but the separation is still poor and there's room for definitely some improvement to be done. All right, now we're going to go ahead and analyze this data using the Functional Data Explorer. That will be under Analyze, Specialized Modeling, Functional Data Explorer. Now I'm going to put my intensity here as the Y, my time as the X, my batch ID as the ID function, and then my 2 factors that I'm changing in this experiment as a supplementary. With that, I'm going to press OK. All right, so this is the Functional Data Explorer window that JMP has created here. You can see that all our different runs are being laid out here on the bottom. We have that target function where we have that really nice separation of peaks that we will want to use to optimize our peaks towards. So you can see here that on the right here, we've got different commands that you can use to kind of pre-process your data depending on what they are. For example, in this case, before we start any sort of pre-processing, I want to first load my target function. This is that target with the really nice separation that I want to optimize my peaks towards. Now, once we've loaded that target, I can then apply some pre-processing. And the first thing I want to do is to align that maximum, right? So all these high peaks are our region of interest, and they have shifted along the x-axis depending on the flow rate. And I want to tell JMP to align the maximum so that everything is within the same axis. So let's click that. And you can see that the steps here are being recorded. And if I just made a mistake, I can simply click this, remove last step, and I can make that simple, fast correction. So now that I've aligned the maximum, I really just want to zoom into this region of interest because all the other peaks corresponds to different compounds that I'm not really interested in. So to do that, I will go to the cleanup and filter it by the X. So let's filter it through these regions at -1 and +1. We'll press OK. And now JMP has zoomed into that high peak and just focus on this region of interest. There are also other commands that you can do. For example, with spectral data, there's some baseline correction here and Savitsky-Golay that you can apply. In this case, I don't really need it, so I'm not going to do that. So now that we've cleaned up our data and we focus on the area and region that we want, we're gonna fit a model. So under this red triangle here, under models, we're gonna fit a wavelet model, which is a really good model to fit spectral data with a lot of peaks. And JMP has fit all these different wavelet model and picked the best one. And you can see how well that fits into our different runs here. And after that, we can then go to the red triangle and go to a functional DOE analysis. Now, what we get here is this profiler, which is a visual representation of our model. We can see how very easy and interactive it is. We can see how changing our factors from low to high flow rate influence the shape of our curve. So instead of looking at numerous raw graphs, we have just this one simple clean visual from this profiler where we can see that effect of our factors. Now you'll notice that there's our buttons here to optimize target. So again, a reminder, the target that we've loaded into is our ideal curve where there was that nice separation of peaks. So once I click this button, JMP will use this model and predict the factor settings that will provide us the closest approximation to that really nice separation. So let's do that. And this is the settings that JMP has predicted, the temperature of 50 and a flow rate of 1.5. So this might be something of interest to find out what factor settings can be used to optimize your peaks of interest and your ideal curve. As you can see, it's just really a few clicks away, and it's a really time-efficient process instead of looking at each individual raw graph a single time. So that is going to be the end of this demonstration. Thank you so much for your attention.
Thanks, Owen. That was a really great illustration of the power of modeling functional data directly. It ensures that we use all of the information we're recording from our instruments, make sure that we're maximizing the value and utility of that data. And at this point, I'd like to bring David back into our conversation so that we can get his take on modeling functional data. Just wondering, David, could you comment on how we might model these types of data without a tool such as the Functional Data Explorer, and how easy it might be to share the insights we develop from those methods with non-experts?
Well, generally, nowadays, there's almost functional everything. So there's functional clustering, functional principal component analysis, functional partial least squares, etc. Now, functional clustering, for example, is difficult because of the complexity of really identifying meaningful clusters. And if we talk about PLS and PCA, so partial least squares or principal component analysis, honestly, I would say that already the non-functional versions tend to be quite challenging for most people. So I'm not so sure about the success of communicating results obtained by these methods. In other words, as we just saw in the demo, I really think that the Functional Data Explorer, I would still say it's not trivial, but it's a huge step forward in making functional data analysis accessible to everyone.
Yeah, thanks for that, David. Yeah, I have to say I agree with you. I think those traditional methods can be very effective, but it's often, certainly for me at least, difficult to communicate the output of what it's actually doing to non-experts. And I think, when we simplify that communication, just like we saw with model screening, it democratizes the process and allows everyone to focus on the value we're getting from those insights, not just those small data science teams. And as I said, we're going to have questions from the audience. So it's not just me asking David questions today. If you still have any that have come up, feel free to put them in the chat and we'll try and get to them. But just to start with, I just wanted to ask a general question that's come in, which is essentially, look, I understand predictive modeling can answer many questions, but my data is spread across many locations, many users. How do I know if it's worthwhile to try and model this type of data?
Well, honestly, you can't know ahead of time. But I would recommend to start and focus on the small wins. So just to build some confidence in the methods, and then hopefully you can grow from there. So if you try and attempt to build a simple model on some of the data, maybe you can start to see what is missing and what other data might be required. And by the way, it's really important to remember that your goal is not to explain 100% of the variation, which typically will be impossible anyway. But all you need is to solve enough to help with, for example, one real business issue that you have. So talking about predictive modeling, one should quote George Box at least once with his famous, all models are wrong, but some are useful. So once you've built a model that can help you with one task, you did a good job and you can just move on to the next problem.
Yeah, I think absolutely right. I tend to look at those initial steps almost as, can you build a model that shows you the direction of travel rather than explaining everything? If you can predict where your process is going to run well, in that first stage particularly, it doesn't really matter if you can predict it to the nearest fraction of a percent. But if you know that your conditions are going to result in an advantageous outcome, it's a great way to start and a great way to convince yourself it's worth trying. So Just looking at the questions that have come in. Move that one over there so I can the camera. So one of the other questions that comes up a lot, and it's come in today, is kind of how does JMP differ from other tools that people might use, be it other software such as KNIME or maybe Python or R? And how does the JMP provide me an advantage for predictive modeling?
Okay, so from my point of view, I mean, obviously there are other tools that you can use to try to do the same task, but one of the main advantages that I see with JMP is that it's very accessible without any need to be a good programmer. So you can start using JMP very quickly through the menus, and it will, as you've seen in the demos, already give you an incredible amount of options and models that you can start to use and analyze your data with. I mean, once you've got familiarized with JMP, you can then start using JMP scripting, and this will allow you to automate the process as well. But especially in the beginning, you don't have to do that at all. You can just use the menus and it will give you everything you need. And the second thing that I would like to mention maybe is that in JMP, there's this principle that graphs come first. And I think this is very helpful, especially for non-statisticians, to understand the results of their analysis. So the interactivity, the focus on graphs, and the ease that you have to use it, I think these are the main advantages that JMP has over its competitors.
Yeah, I absolutely agree with that. I think part of it, like you say, touches on your earlier point around EDA, where if we can draw a picture of our data, it's oftentimes far more useful than just creating simple descriptive statistics. We've all seen examples where we think we have a nice mean and standard deviation, but our data is kind of quite different. But that ease of use, I suppose, then it folds into another question we get asked a lot, which is what's the risk that making it this easy has? So, if we make it really easy for a non-statistician, so make it as scientists and engineers are building these models, how do we guard against the generation of models that are ill-defined problems, overfitted problems?
Well, the first thing that comes to my mind here is that it's amazing that today this is the topic that we have to worry about, that we give too many tools to non-statisticians. I mean, that's exactly what Deming wanted, right? There's this famous quote by him, statistics is too important to be left to statisticians. So in some sense, that's exactly the goal that we had. Now, to come back to the question of overfitting and concerns like that, I think this can be answered on two levels. On one side, we just have technical tools to prevent from overfitting and other issues that your model might have, like using a validation and a test set and things like that. And on the other hand, if we look at the people, your domain experts are, of course, the most qualified ones to understand and interpret the results. So ideally, you would like them to be as close as possible to the modeling process. And of course, I mean, it cannot harm to upskill these employees. And I know that JMP has everything you need, like the modeling workshops and steps to get everybody started with that.
Yeah, I think absolutely. I think we touched on several times that making that communication of data and models easier across organizations, and I think it can only be helped by upskilling your employees, and it generally moves it lets people work on problems that are difficult relative to their level of expertise, rather than relying on doing relatively simple models with very experienced statisticians. And then I've just had one come in while we've been talking to follow on that. And someone's asked, what's the difference between machine learning and multivariate methods for predictive modeling?
Well, I'm not a big fan of there's a similar question. What's the difference between predictive modeling and machine learning, and what is part of statistics, and what is part of machine learning? And people actually fight about the question if logistic regression is actually a statistical method or a machine learning method. And for me, these questions are not that relevant. Use the tool that is useful for you. And if it's a multivariate method where you typically have a higher dimensional response variable, or if it's something that people traditionally will call machine learning, like KNN, for example, whatever is useful for you, just go ahead and use it. And I think that the discussion, what method belongs to what field, you can just leave to others.
Yeah, I absolutely agree. I think for me, my interest has always been the application of these tools rather than the semantics of what's machine learning and what's statistics. And, if it's useful for what your problem is, use it. We've had some more great questions come in, but given the time, I'd just like to wrap up now. I'll try and make sure those questions get answered in a blog post in the coming weeks. I'd just like to firstly thank David again for bringing your insight and experience to our discussion today.
Well, thank you very much, Stuart. It was a real pleasure to be here.
Oh, thank you. So today we've heard and seen some real-world examples about how machine learning methods can build predictive models on our data, how we can use these to efficiently understand what our data is telling us, maximizing the value you get from it. So our goal here today is always to try and inspire you to try these techniques and methods out for yourselves, to apply them to your own challenges in your work. And if you haven't already, encourage others to do the same. So we'd love you to share the stories you heard today with your colleagues or the other similar ones that are on our website, jump.com. And the customer stories that we have are all arranged by industry, so you can help find the most relevant ones for your situation. And just before we wrap up, please could you just make sure you answer our poll just to indicate whether you'd like to receive notification from Jump regarding future webinars such as this and other training series, as well as some of the other relevant resources. So while that's running, I'd just like to take the opportunity to say another huge thank you to David Meindrup for taking the time to speak with us today. He did a really lovely job of answering our questions, adding real value to the conversation, and it's been great to hear him expand on how predictive models can be used to accelerate your processes and decision making. Hopefully, you've also seen from the demonstrations just how easy and accessible these analytics tools can be. And I hope it's given you some ideas about where you might be able to start using this in your own work. Once again, if you need help with that, we're here to help you. And you can find lots of help on our website, but also you could reach out to your local support team. There's a list of your local offices on the website. But if in doubt, just email. So to summarize today, we wanted to leave you with a clear understanding of how we could get started with applying machine learning or predictive modeling tools to our data so we can maximize the value we're going to obtain from it. We wanted to see the importance of using our domain knowledge, experience, and intuition alongside these methods rather than as a replacement. We want to illustrate the impact that the quality and structure of your data has on the questions you can answer from it. And most critically, we wanted to leave an understanding of how data-driven processes and analytics could deliver explainable insights into your data. Hopefully, you've seen how all of these can be achieved. And I'm sure there are many of you who would like to explore how Jump or Jump Pro might be able to help you and your colleagues get better outcomes from your hard work. So if you're not already using JMP or would like to explore what JMP Pro could offer you, I'd love you to contact your local representative, either using the link in the chat or via our website, jmp.com. As for the modelling workshops we've talked about, these details will also be shared with you after the event by email. Thank you for your time today, and goodbye for now.